Okay, here we go. All right. So if a weightlifter doing the snatch is, you saw two examples of the snatch, so I got to keep track. This is track 3. All right. So that weightlifter who did this, did the snatch, I think it's a young woman that I had saw. How much work does he or she do? 77 kilometers or 77 kilograms, 2.5 meters. Before this, we need to know how much force. Remember, force is mass times acceleration. All right, and the acceleration that we have to overcome, or the acceleration we have to provide, is we have to overcome gravity. So the force is equal to mg, which is actually F should equal ma here, and then F equals mg, and then where g is 9.8 meters per second squared, and that's where we're lifting up in this case. 77 times 9.8 meters per second squared equals 755 newtons. Lifted that 2.5 meters. So it's 1,887.5 joules. All right. So now watch this next thing. So this was kind of a short little thing. So let me write that out so you can see what it looks like real quick. All right. And then we'll compute the joules for the lover's leap guy. All right. Ah, shoot. It's going to take a second. All right, so I'm going to try and write a little bit bigger because I got a email, not from someone in this class, but someone in my backyard physics class, and they said they were having trouble reading it. Well, one, my handwriting is probably atrocious too, but anyway, what were we looking at? We said the mass was equal to 77 kilograms. The acceleration was equal to 9.8 meters per second squared going up, which is equal to a g. 1g is 9.8 meters per second squared. And force is equal to mass times acceleration. That's the big idea that we're doing here. Mass times acceleration. And then the work done is equal to the force times the distance. I like using the d instead of the s that we have here. So 77 times 9.8. Equals 755 newtons times the distance was 2.5 meters up. Joules. That's the energy unit. Joules is the energy unit for energy. Is the unit for energy unit for energy. That made no sense. All right. So